Hello and welcome to chapter 27 of this Flutter course. In the previous chapters, we've been talking about our user interface, and also we've been looking at our services, and we've put some time also to create some tests for our services and providers. Up until this point, we've been talking quite a lot about like the logic of going from one screen to the other, integrating with Firebase, etc. However, we haven't actually talked about storing user created content inside our application or inside some sort of a cloud service. What we're going to do in this chapter is we're going to talk about SQLite and storing user generated content, in this case, the user generated nodes, inside SQLite. Now, I'm going to get to what SQLite is, but first of all, let's have a look at the title of this chapter, which, as you can see, it says CRUD local storage. For those of you who are software developers from before and are comfortable with CRUD, you can just jump over this part of the chapter. For those who are not familiar with CRUD, CRUD stands for create, read, update, and delete. These are four very fundamental operations that any developer would perform on their data. And for instance, if you're a Flask or a Django developer or a Node Express developer, you're probably already familiar with these because you're probably using some sort of a database, MySQL or SQLite, and you're storing your data in there and you're just working with the data and you're familiar with the term CRUD. But if you're not familiar with it, then think of it as C, which is create, is you creating some sort of an object inside a database, such as, for instance, a user generated node. You read, of course, want to be able to read that data back. For instance, in our application's main user interface, you may want to read the entire contents of the database. Not the entire contents, but at least the user-generated nodes for that specific user. So that's the R in CRUD. Then you have U, which stands for update, or it doesn't stand for update. It means update because U is the first letter of update. So an update is, for instance, if I have already generated a node inside this application, I want to go and change the contents of that node, then that's the U in CRUD. And last but not least, you have D, which is delete. And as its name stands, basically, you allow the user to be able to delete their own generated content from the database. So what we're going to do in this course is to talk about SQLite, that is a database or a C library, a library created in C that allows us to, the C as a programming language, C, that allows us to store data inside a file. Now, if you're coming from like the backend world, if you're programmed with inside with Python in Django, you're already familiar with this because SQLite is the default database that will be provided to you in Django. And a Flask as well, I believe, is using SQLite by default, which is very similar to Django. But if you're not familiar what SQLite is, I've prepared a website here, which is, I haven't prepared the website. I've just opened the website. So you can see here, I'll increase the size of the font here, and you can see SQLite is a C language library that implements a small, fast, self-contained, high reliable, full-feature SQL database engine. SQLite is the most used database engine in the world. Well, just think of SQLite as the database engine that we're going to use in our application. And it's not something that is built inside Flutter. We will have to use a so-called plugin for it. But that's also okay. Not many languages have support for talking with a database natively. So, but we'll get there. We'll get to that point, okay? Now, let's talk about how we're actually going to integrate with SQLite. And to start with, so I'm assuming that you have never worked with SQLite before, or you haven't worked with any type of database before, and you're trying to learn how to do that. Okay, so that's been my assumption from the beginning of this course. So if you're already a seasoned developer, you know exactly how SQLite works. You may want to jump over this section of this chapter and get to like more juicy parts where we integrate actually with SQLite inside the Flutter application. So let me close this, or maybe let's just keep it open. What I'm going to talk about now is a free program called DB Browser for SQLite. You see, SQLite allows you to, if you think of SQLite has different components. First, you have your database, which is just a file that sits on a disk. And then you will have the SQLite engine that can read from this file and write to this file. So that's the engine. And then this engine should run somewhere. So it's either going to run inside an application, such as the one I'm mentioning here, a DB browser for SQLite. Okay, so SQLite's like baked into that application. Or you can also bring SQLite into your terminal so that you can actually talk with SQLite databases from within your terminal. Or if you, for instance, have installed Django on your computer, then you can use Django in order to integrate with SQLite. So SQLite is the engine that talks to the SQLite files, which are your databases. But then this engine should run somewhere. It's not just an executable that, like, you say, here, take this file. You now have to have like some sort of a container where the SQLite engine basically resides. When we then talk about our Flutter application, we're going to bring this engine into the Flutter application so our app can talk with that database. But for now, we're going to look at a program called DB Browser for SQLite. DB Browser for SQLite is a free, and I believe it's an open source program. Let's search for it. I'm going to say DB Browser for SQLite. And we end up in this website. And as you can see, the official home of the DB browser for SQLite, and this is how the program kind of looks like. I'm not sure if, yeah, I can see now it's actually available for Windows, Mac OS, and it would be amazing if it was available for Linux as well. Yeah, so it seems to be available. And you can actually use Snap, so that's great. So if you're on Ubuntu like I am, not on this machine right now, but if you're on Ubuntu, you can actually use Snap Store or even Debian, any type of operating system, Linux-based operating system that has Snap Store. So that is really good, even on Arch Linux, fantastic. All right, on Debian you used apt, so that's fine. But anyway, so it's available for Windows, Linux, and Mac OS. So I need you to basically go to SQLite Browser, or DB Browser, as it's called, DB Browser for SQLite. If you go to the homepage, I need you to find this website. And let me change the screen layout so you see it better. And I need you to download this program, okay? I've already downloaded it on my computer. So I'm going to close that Safari window, and I'm going to bring you the DB browser for SQLite as it looks like on my computer. The only thing I've changed on my interface here is I've changed the font from 13 to 20, not because I don't like the number 13. It has nothing to do with that, but it's just I thought 20 is a little bit of a nicer font size for this course. All right, so what are we going to do now? So let me then talk about the structure of our database and how we're going to set it up. If you think about how we've created our user interface, in that here's the user interface. If we go here, you can see that we can register with different users. So then we have a user entity, or a user table, as we're going to call it. And then we also have, we are going to allow the creation of these users in our database. So imagine that we will have some sort of a table, some sort of an entity in our database that is dedicated to users. And users are probably just going to have what are they going to have? They're going to have an ID and an email. So as you remember, when you register a user with Firebase, you always get a user identifier. So we're going to store that ID plus the user's email in our database. Okay, so we're not going to store the user's password. That is an absolute no-no. Okay, so user ID, which comes from Firebase, and the email address we're going to store in our database. And also, we are going to have another table in our database dedicated to notes. So as a user, when I log into the application, I should be able to create my own notes. And these notes should be kind of like bound to, and like they should be glued to my user. So if my user is in the database, I should be able to have notes. And if my user is deleted, all those notes should kind of also be deleted from the database. So it's kind of like a cascade for those of you who are familiar with backend development. So that is like the structure that we're going to set up for our database. So I can see in my notes that for our notes table, we are actually going to have a user ID integer in that table that like binds the every node object to the user who created it, but we'll get there, so don't worry about it. So I'm going to get rid of this here and put it there so we don't see it. Now what we need to do is start testing. So we want to create a database, a simple database, and start creating some tables in there. Okay, so what I need you to do is just to press the new database, and I'm going to save it on my desktop, and let's just call it testing. Okay, and I'm going to press the save button right there. Okay, you can see now we created a database and we have a table here. It doesn't look so nice. I mean, it's not rendered so fine because I've changed the font on my screen, but I think you get the idea. Okay. So what we need to do is to, as the caption says, we need to create a table called user. Okay. So go in here at the table section in here, and I'm improvising a little bit here because this is like something that I planned to show you, but I haven't actually prepared any notes for it. So let's just go ahead and create a table here called user. And as you can see, we're going to be able to have some um, fields in here. What is called a field in here is pretty much just like a column. So by creating a field, you're creating a column. Okay. And the great thing about DB Browser for SQLite is that you can see the SQL code that will be generated for you, which we're actually going to use later when we integrate SQLite into our Flutter application. But for now, I just want you to get the idea of how SQLite works, how it creates the tables, etc. Okay. So now we have the user empty table. It doesn't have any fields or columns. I need you to press this add button right here. And what we're going to do is we're going to just create an ID field. Now, if you're not a developer or software engineer from before, you may not know about ID field and why it's important. Or if you're a developer from before, you may know ID as primary key from before. So an ID is just usually an integer identifier. An integer is a number. So a number identifier for every row that you'll later insert into your table. So why is it important? Because usually an ID is something called a primary key, and a primary key by default is unique. What that means is that for you to be able to create a user in this table, it has to have its unique identifier. Now, if you remember how our how we are basically treating users in our user interface is that we're treating them by their email. So you may think, well, the email is a unique thing as well. So why don't we go with uniqueness of the email? Well, we can apply uniqueness constraints on the email field or the email column, but it is very well established pattern in database world where you're working with databases that you can make a string column unique, such as an email, but a primary key is usually an integer such as pk or id. So it's just a convention, and it's also good practice to not go with like a uniqueness of a string, because it takes more resources in order to calculate the uniqueness of a string than it takes for an integer. So we're then going to call this field ID. It's going to be integer, and there are some fields in here which are not rendered so well. I'm going to increase the size of this, and I'm going to do like this. Okay. So what we're going to do in here, we're going to take, you see NN in here, and the type we're going to leave as integer, that's fine. NN means not null, meaning that this field should always be present. It should never allow the value, an emptiness of a value or the absence of a value to be present there, okay? The absence of value to be present. I hope that makes sense. Basically just means that a value cannot not be there. So we're going to leave it like that. PK stands for primary key, and that is what actually I can move my mouse over them. That's great, primary key. So it means that it is the key using which is a unique key in this table, using which we should be able to then easily query different users from this table. So what we're going to do is we're going to tick this item right here, okay? AI is auto increment, I believe, and auto increment is a great functionality in SQLite and many other databases that allows you, as the name suggests, as the name indicates, that by you creating, for instance, a user with a specific email, and you insert that user into the database in this table, And you don't even have to assign an ID to that user. You just say, here is the user email, boof, put it in the database. Then excuse me, then SQLite is smart enough to say, oh, but I need an ID field as well. You haven't provided it. And then it looks at this field and says, oh, ID is auto increment. So it's going to create that ID for you and increment the previously generated ID and assign the new ID to your object. For instance, if you have no objects inside this table and then you add a new user, then it automatically gets the ID of 0. And then if you generate the next user and put it in there, then it will get the ID of 1. So you get the idea. Okay. And that is exactly what we're going to do for this particular field. And unique is just, yeah, as its name indicates, this field needs to be unique. But if you indicate something as primary key, implicitly it is a unique field. Okay. And to be honest with you, we could actually check not null as well, meaning that, yeah, it should always be there. So just in case. So that's for the user field. Okay. Sorry, it's for the ID field. And now let's go ahead and create a new field for the user's email, like this. And for the email, you should say that it is a text, okay? And what we'll do, we'll say it shouldn't be null, and also the emails are unique. So have a look at this now. It generated code for you that says create table user, ID integer not null, email text not null unique, and it sets a primary key of ID with an auto increment. So this is kind of like the code that we're actually going to use in our Flutter application in order to programmatically create this table later. But for now, just keep it in mind. This is kind of like the syntax of creating a SQLite table programmatically. Okay. All right. So then you can press OK in here. And now you can see the user table has been created for you. And here's the code for it, or the schema, as it says right there. All right, great stuff. Now, as we did the user table, we need to go and create our notes table, because remember from before I said we're going to allow the user to create notes when they're logged into the application. And by the time they're actually logged into the application, we should have already created a user row for them in the user table. And then by creation of every note, we're going to create also a new note in the database in our note table, which we're just going to create as the caption indicates. And then we're going to bind that note to that user in the database. So I need you to go here then, and then we need to create a new table by pressing create table button. Okay. So as the caption indicates here, let's call this new table note. And we're then going to start by creating a new field called ID. And we've already gone through this. You know exactly what to do in here. An ID field as integer, and we say it shouldn't be null. It should be primary key, and I think that's it, to be honest with you. So not null, and auto increment as well, of course. So all right, so that's for the ID of a note. Now, what other fields do we need in here? So what we could say is, for instance, that you have a user ID. So you want to bind a user to a note. And what we're going to do in here, we're going to bind this. We're going to say literally that this, oops, where did it go? Oh, it's a little bit strange interface in here, so that's okay too. So user ID integer, and we're going to say it's not null. And also what we're going to do is what we want to do is for this user ID to be kind of like bound to a user table's ID field, and that's called a foreign key. So you have a primary key, which is the key that your table itself manages as its own field, and then you'll have a foreign key, as its name indicates, that it is a field inside your table that is bound to another table's something else column. So in this case, our user ID should be bound to the user table's ID column, and you can create that with DB Browser for SQLite inside constraints. And in here, let's see, we add a constraint and we say we have a foreign key. And in here, so let's say SQLite foreign key, and we say the user ID, and we say apply. And you can see now it says foreign keys or ID references. It's not at the moment referencing anything. So I wonder if that field is hidden somewhere to the right-hand side. and how we could possibly create that. Let's see. I just remember from before that this was a little bit strange to get working from the beginning. So name, oh, maybe it's the name right there. So let's say user ID references SQLite foreign key. Let's see how it's created. Foreign key user ID references. Let's just say name. Should we say in here? If I say blah, what happens? Foreign key user ID references contains blah. So that's not really what I wanted in there. So I'm gonna remove this blah that I just created, and let's see if we can change the SQL. We can't. Are there no other fields available here that we can play with? Perhaps not. And I want to remove this just to see if I've made any mistakes in there. So let's say, so here I can see we have a user ID and then there is a foreign key. And I can see here, this is perhaps the right actual way of doing it. I remember there was something really strange about it. And now I remember that it is hidden under this foreign key column. Unfortunately, I believe it's a little bit of a strange interface. That's okay. I'm just still very, very grateful that we have DB Browser for SQLite as a free software and perhaps even an open source software. I'm not sure about that. And I'm very grateful for every developer who's worked on this. So I just hope that that's understood. But what we're going to do in here, we want to bind this user ID to the ID field of the user table. So just click here under foreign key and double click. Actually, I can see then this magic thing appears here. So let's go ahead and say that we want to bind this to the user table ID field. And I believe that should be it. Yeah, and you can see now the code generated here says we have a foreign key called user ID and it references the user table ID field. Okay. Perfect. Now what we also need to do is to create another field in here, and that's the text of every note. So what we're going to do for notes is going to be very simple. Our notes are not going to include any sort of, they're not going to include any sort of, for instance, images. They're not going to include any sort of ordered list or unordered list. They're going to be simple texts, okay? And they don't even have titles. The title of a note we're going to derive from the text of the note. So it's very simple. So for the text of the note, let's just go say it is of type text. And I believe that's all we need right now. So user ID, text, and yeah, that's fine. And also, to be honest with you, if you want to, you could also create other fields in here. You see, in this course, what I want to do in the beginning is to allow us to create a local database that you can store all the users' notes in it. But I want you to also be able to later in the future get rid of this local database and replace it with Firebase. That's like the goal. However, some of you may actually decide to keep this local database, store the user's information in this local database, and not the user's information, the user's notes in this database. And then you may want to decide to have some sort of a utility service that sits in the background and syncs these notes with Firebase at appropriate times. So that's up to you. If you want to do that, then you may want to actually create a little field in here that's called is synced with server, something like this, okay? Or is synced with cloud, I've called it in my notes. So let's go ahead and do that. Although we're not actually going to use this field, but I just want to demonstrate to you that this field is possible to achieve with SQLite. Then in here, let's say it is an integer also. And we're going to say the default is 0, meaning it's not synced. Basically, true or false in true could be translated to any value that is not 0, and 0 could be translated to the value of false. So putting the value of 0 in here, meaning that it is not synced with any cloud storage. So let's then go ahead and say that this is integer, and it's we should say it's not null, and it doesn't have to be unique. So now you can see that this is the result of the creation of our table. So it says ID integer not null, and the ID is also primary key in auto increment. Then there is a user ID, which is integer not null, but it's also a foreign key to the user table under the ID column. or the ID field. And then we have another field here says text of type text. And then another field that's called is synced with cloud integer, not null, default 0. Okay, so that's all we needed to do. And I'm going to press OK, and I need you to do the same thing on your side. All right. Now we have two tables in our database. So let's go ahead and move on to the next point that we're going to talk about. You see, as the caption indicates, we need to create these programmatically. Otherwise, we have to move this database that we just created called testing.db manually into the documents folder of an application. I'm going to explain what this actually means. You see, now we have a file called testing.db. It has the database for our application with some tables, okay? However, we need to be able to create these tables programmatically if they don't exist inside our application. You see, this testing DB for me is sitting on my desktop. It has absolutely nothing to do with our Flutter application. And you could be smart and like drag this DB into your Firebase application, Flutter application, and then kind of copy it to the right place when the application is executed in the user's telephone or on the tablet, and then try to read from that database. It is possible, but what I'm going to do in here is I'm going to show you a better way of doing this, in that we're going to actually create these tables programmatically in our Flutter application, so that you also see that process and how that works. How can you integrate with SQLite inside your Flutter application? Okay. All right, so in order to do that, as the caption indicates, we need a few dependencies. We need SQFlite, path provider, and path. And I'm going to then explain to you why we need these dependencies. You see, SQFlite is a third-party package that we need to add to our application in order for our Flutter application to be able to talk with SQFlite. So that's that, and that is for the storage, the actual storage and talking with the database that package is used for. Okay. Now there is a dependency that we have to drag into our application called path, and path is used for us to be able to grab the application's documents folder, so that we can actually create a file inside that documents folder and place our data inside that file, just like I'm placing the data for nodes and user inside this testing DB file on my desktop. So the path provider, I may have actually said path, but it's actually called path provider. Path provider dependency allows us to grab the application's documents folder. If you're not familiar with mobile application development, you may not know this, but applications that sit on on an Android phone or tablet and on iOS telephone or iPad OS tablet, they have their own file structure. So every application in itself has a document directory. So whereas on your computer, like if you're sitting in front of a laptop or a desktop, you have a documents folder that other applications that run on your operating system could get access to. So it's one documents folder. Every application can request access to it and store information in it and read from it. But that's not the same concept in mobile devices and on tablets, in that every application runs inside something called a sandbox. A sandbox is like a cage inside where the application resides, and all the application data resides in that sandbox. So every application can request access from the operating system to read its own documents folder. Okay, and that is what the path provider package is going to allow us to do, to find our application's documents folder in which we're going to store our database file. Now, we also need, as I mentioned, a package called path, and we need this path just for a very simple operation. And let's say that we have used path provider to get our documents folder. Now we want to create a file in this documents folder and kind of like get the full path of this file, documents folder / this file. And that's what we need the path package, because it has a great function called join that allows us to take the path of a directory or a folder and join that path with a file name, and it gives us the entire path back so we can access that file. Okay, so a lot of information. I'm gonna take this into another screen so you don't see it, and I can see here it's asking for to control this computer use access. I'm gonna deny that for now. All right, so what we're gonna do, I'm gonna bring our code up if I can find it. And here's the code how we left it in the previous chapters. And I can see that it is running, excuse me, in strcpy. I'm going to bring it here. I'm not actually sure if we need strcpy in this chapter, so it may be better for me to just to minimize strcpy. And I'm going to make this code a little bit bigger here as well. Okay. So, so what we need now is to first, before we go ahead and actually create our notes service, is to bring in those dependencies. Okay, let me change this screen layout a little bit so you see better. I'm going to increase the font as well. So I need you to go to your editor, text editor, or IDE if you're using, and we need to bring in those dependencies. Okay. So let's go and bring up your web browser and say pop.dev, and in pop.dev search for SQFlite, okay? And you can see it's right there. And the way to install it is very simple. You should be able to just say flutter pop add SQFlite. So let's go ahead and do that by hand. SQFlite. Remember, it's not SQLite, it's SQFlite. Okay, that dependency has been added. Then I'm going to say Flutter pop add path provider, and we can actually search for it in pop dev path provider, and it is right there. It's developed by the people who have brought us Flutter. So to begin with at Google, so it's not really a third-party application or third-party package. And we can actually have a look at SQFlite as well and see who's developed that. So it's another, it's another publisher. It's not Flutter themselves. So let's go back to path provider, and I'm gonna just say installing, and we can see it's Flutter pop add path provider. Let me just copy that and paste it there. Add path provider, and then we also need path. So let's go back in here and just type path. I believe this is by Flutter team. Yeah, Dart Dev. So let's just say Flutter pop add path. All right, that's going to do its work. And now if you go to our PubSpec YAML, then you should be able to see those dependencies. SQFlite, path provider, and path are right there. Okay. Now that we've done that, we can go and do what we are supposed to do in here, which is create our notes service. You can see that in the description I provided here in the caption, I said that we're going to create inside a folder called CRUD. And we already have lib services. You can see in here, lib services and lib services auth, but we don't have CRUD. So I'm going to go in here in lib and just say new file. And I'm going to say services slash, it's saying that it already exists. So inside services, I'm going to say new file. Then I'm going to bring it so you can see it as well. Oh, where did it go? Services, new file, CRUD. I think I need to change the screen layout. So unfortunately, so you'll see it better. Services again, new file in here. New file, third time or fourth time lucky. CRUD, and then notes service dot. Okay, so what we're gonna do with this note service is to basically grab a hold of our database. It is the primary service that is going to work with our SQLite database. It's going to grab users. It's going to create new users, delete users. It's going to find users. It's going to create notes, delete notes, update notes, everything that we need from our user interface. This note service is going to facilitate that for us. Okay, so what we need to do inside so what we need to do now is to actually, I think before we do that, we need to import our dependencies. So let's import our dependencies. We need 3 dependencies, if you remember: path, path provider, and SQFlite. So I'm gonna bring those in here so we don't have to type it again. So imports are kind of like boring, and I'd rather not type them. So let's go in here and you can have a look at what I've imported here. Package SQFlite, and then we import that. Then we also have the path provider, okay, so that we can get the documents folder for this application. And then we also are importing package path, and then I'm doing this show syntax in order to bring in this particular function called join. All right, so you could also skip that, but the problem is that then you get everything inside path.dart, and that's not what I want. So I just want us to get this particular function inside path.dart. And you could also do the same thing in here, to be honest with you. You could just say show, and I think the function is called get application documents directory. So let's do that. Why not? Let's just get that particular function from path provider as well, okay? We don't need the entire path provider. All right. All right, that's great. So what we need then is for us to be able to grab a hold of our current database path. As I mentioned, every application that you develop with Flutter for mobile devices such as Android and iOS and iPad OS, they have their own documents directory, and we're going to create and we're going to get the path of the documents directory, and then what we're going to say is we're going to join that using path dependency with a name that we are going to specify for our database. Okay, so what we need to do then is let's go ahead first actually and take care of some other important matters that need to be dealt with before we actually create the functionality for our database implementation. You see, node service is going to talk with database, but before it can do that, it needs to have some sort of Dart representation of those two very important tables that we created, user and note. So if you read that data from the database, how are we going to represent it inside our Dart application? And for that, we need Dart classes. So what we need now is to, as the caption indicates, we need database users, create a class called database user inside nodes service Dart. All right, that is going to be a bit of code, so I hope you're ready for it. And let's just go ahead. I'm looking at my notes. Let's go ahead and create, as the caption indicates, we create a class in here. I'll make the a little bit bigger class, and I'm just going to say database user. Okay. Now, if you remember from DB browser for SQLite, I'm going to bring it here. Every user had, can we actually, oh, we can browse it, but I want to go back to the user and modify the table, save it. And you remember it had an ID and an email. ID was integer and email was text. So that's what we're going to define in here. Okay, so we're going to say final int ID and final string email. I'm going to get help from Visual Studio Code to complete this. I'm not going to explain these again and again because we've explained this quite a lot in previous chapters. So by this point, I just assume that you know what these are. Let's make this a constant initializer, and then let's go ahead and say these two parameters are required parameters, so they become also named parameters by default. Okay. That's that. Put a comma here so we get Dart formatter to do its magic. And what we're going to do is remember when we actually you shouldn't remember because you don't know this maybe yet, but when we talk with our database, we are going to read like hash tables for every row that we read from our from that table. So every user inside that database table called user is going to be represented by this object, a map of a string and an optional object. Okay, so that's a row inside the user table. Now imagining that this node service that we're going to create soon reads these users from the database, and it should be able to pass this to our database user class, and the database user class should create an instance of itself depending on the values inside this map. All right, so let's go ahead and create a constructor. We call it database user, and then we say from row, and then we say we get a map of a string and an optional object in here, and then let's just call it map. Okay, so what we're going to do in here is we're going to create the shorthand for creating and constructing our object, and we'll say the ID is equal to, inside this map, there needs to be some sort of a column called an ID column. So instead of hard coding that in here like this, let's go and define a const in here and just call it ID column. And let's just say that this is equal to ID. And in here, we're just going to say ID is equal to ID column, just like that. All right. And then what we're going to say is we also need the email. And email is equal to map. And remember, we have the email. I'm going to open the user in here. Modify table. And let's go and have a look at this email, which is text right there. Okay. So the table, the column basically is called email. So let's go ahead and create const. I'm going to make this a single code as well, because that's like the preferred way of doing it. And let's call it email column. And I'm going to assign this to equal email. And in here, I'm just going to say email column as a string. And this should be as int. So this was, I mean, it looks complicated, but it really isn't. So, and you can see it's a constant. So we could also actually tag this as immutable. And we need to import foundation in order to be able to do that. Okay. Now that we have our database user, we need to also implement a few more functionalities for this class before we're actually done with it. So the three things that we need to do for it is first to create like a string descriptor for this class, so that if we're printing out these user to the debug console, otherwise, I mean, before I say otherwise, if we're printing out an instance of the database user to the debug console, so we're looking at the various users that are inside our database. If we do not implement toString on our class, it's literally just going to say instance of database user in the console, and that's not so useful. So it's my habit to, if I'm planning to print out these things to the console, it's my habit to go and implement toString. So let's just in here say toString, and you see it gives us the override. And what we're going to do in here is just we're going to say a person ID is equal to $ID, and email is equal to $email. Okay, so that's for your toString. Then what we need to do is also implement some sort of equality behavior for our class. You see, we want to be able to see if two different peoples that we've retrieved from the database are equal to each other or not. So if I say if person X is equal to person Y, then like read the person Y's notes, something like that. So let's go and implement equality for our class. And the way to do that is you override a Boolean operator, and it's called bool operator equal. And then in here, you would have a covariant, which we haven't talked about yet. And I will talk to you right now about it. So what covariant is a keyword in Dart that not many people know about, but it allows you to change the behavior of your input parameters so that they do not necessarily conform to the signature of that parameter in the superclass. So remember, we're doing override here, meaning that this functionality, this operator is already defined at the object level. So let's go to object, just type object somewhere. For instance, void hello, and then say object, and then command click on it just so you can go there and search for operator equal, and you'll see in here that it says extern bool operator equal, and the parameter should be of type object. Now, we don't want to do that. We want our classes to be compared to other classes of the same type. So if you don't put covariant in here, you'll get an error from the analyzer, and you'll soon see that. Actually, we're going to remove that soon. So in here, we're saying that we're going to compare our class with equal, an instance of our class with equal, and we're going to compare it with another user of the same class, okay? And then in here, we're just going to say our ID should be equal to the other ID. That's our equality. Now, let's go ahead then and remove this covariant as I promised you. And now you'll see you'll get an error saying that, oh, wait a minute, according to object, equal should compare the current object with another object. But using covariant, you're telling Dart that, hey, I'm not comparable with other objects of any other class. I'm only comparable with database user instances. So make that happen. All right. So then after you implement an equal, you have to also implement hash code as is suggested by the analyzer. So I'm going to get help from the Dart from Visual Studio Code, and I'm going to say create method hash code. And in the overriding of hash code, I'm just going to return my ID's hash code. Okay, so this basically the ID is becoming the primary key of this class, using which it will hash itself so it can be placed inside maps or hash nodes if you're a Rust developer, or a dictionary if you're a Swift developer. So that's hashing. Okay, so it feels like we're actually done now with this. With our database user. So that was quite a bit of code, but we managed that. All right, now that we've done the database user, we need to do something similar, but this time we need to do it for our nodes. So we have a database user. Now we have to create something called a database node. Okay, note, not node. And I'm going to do that under the database user, just so that we can have closer access to these constants. All right. So I suggest you do the same thing. So let's just say we create a class and we call it database node. And remember from our database schema that a node, so if I go in here and say right click, modify table, then we had ID, user ID, text, and a field called is synced with cloud. All right. So let's go ahead and do that. ID is integer, user ID is integer, text is text or string, as is synced with cloud is just an integer in here, but we're going to represent it as a Boolean. All right. So keep those 4 fields in mind. So let's go ahead and say final ID, int ID. Then we had a final int in our database. We call it user underscore ID because that's a convention in SQLite or SQL generally that you don't put, you don't write your fields with user ID. Usually you don't type like this, the way we type with camel case in Dart and other languages. We just say user, everything is lowercase, and different words are separated from each other with underscore. But that's not the case in Dart and other languages. Instead, we say user ID like this with camel case. All right. And we're also going to create, let me just move this a little bit there. And we're also going to create the string for our text. And last, we're going to say is synced with cloud, something like that. All right. And again, remember, we're not going to use is synced with cloud. It's just for you to understand how we create different fields in the database. And yeah, it's just something that you guard yourself against future changes in your database schema. So by doing this, you're allowing yourself to play with this field so that every node that is locally created in the local database is not by default synced with the cloud. All right. I'm going to get help from Visual Studio Code to complete the constructor for this. And I'm going to go and do all of these fields as required. So I'm going to say required. I'm going to copy that, paste it right there, and there. And then I'm going to put a comma at the end and Command S on Mac or Control S in Windows and Linux to save this and get Dart formatter to format this file for me. All right. So that's the initializer. And we kind of also need to do the same thing that we did here for our database user, in that we need to instantiate it from a row. So let me copy this code the way it is right there. And I'm going to bring it into our database node. I'm going to paste it right there. And instead, I'm going to say this from row initializer creates a database node. In our database node, we have an ID, but we don't have email. So in here, we're just going to say user ID is map. Then we need a new column, which is called user ID column. Okay, so let me just see in my notes how I created it. Yes, I can see it's called just user ID column. So go ahead and create a new constant in here and call it user ID column, which is, if you remember from our schema, it was called user underscore ID. So user ID. Okay. And here we say user ID is equal to map user ID column as a string. And it's complaining right now because we have 2 more fields to initialize, but we haven't really read their values from the map. So text and is synced with cloud. So for text, we're just going to say text is equal to map. And let's go create a new constant in here. We say text column, and that's equal to text. So it's just the name of the field or the column here, you see. So let's go ahead and say that's text. And in here we say text column. And we say add string. I believe that's how we call it. Yeah. And what we're calling a string can be initialized to the field. Oh, sorry about this. The user ID can't be a string. It should be an int. So let's just say it's an int. And last but not least, is synced with cloud. So we're going to say is synced with cloud actually is read from our database as an integer. Remember, is synced with cloud as an integer. So we're going to say, we're going to first define a column for it, is synced with cloud column. And we're going to call it is synced with cloud. And I'm saying we're going to call it, but actually we've already called it. We called it is synced with cloud. So just we need to copy and paste that in here, you see. Okay. And then we're going to say is synced with cloud is equal to. Now, you see, we don't have this data. We don't have this field as a Boolean in the database. We have it as an integer. So we have to read it as an integer. So we're going to say in the map, there's a column called is synced with cloud column, and it's an integer. Okay. If that is equal to 1, then return true. Otherwise, is equal to 1, true. Otherwise, false. So you see what happened here. We read the column as an integer. And we said, oh, if it's equal to 1, then this guy is equal to true. Otherwise, this guy is equal to false, okay? Now that we've done the initialization of our database node from the row, we need to go ahead and we need to create the toString as well for our database node, okay? So let's go and override toString like this, and we're just going to say this is a simple note. We're going to say is equal to note. Its ID is equal to $ID. Its text is equal to, or just its user ID is equal to $user ID, which is a field that we have. And then we're not going to print its entire entire text. Instead, we're going to say is synced with cloud is $is synced with cloud, just like that. All right. All right. So, I mean, optionally, you may also add text if you want to. It's kind of up to you, but the problem is that the text of a node could be so long that it actually gets in the way of you getting information of your class instance, such as its ID, user ID, and its synced with class. So maybe if you want the text to be there, just add it at the end. So it basically doesn't disrupt the rest of the fields that you may actually have interest in reading. Okay. So we did the implementation from toString right now, but we haven't done the equality. So let's go and override the equality as well and the hash code, sorry. I'm going to copy that code from our database user and bring it into the database node. And I'm going to then paste it right here so you can see it as well. We're in the equality, we're saying that we're comparable with a database node. As long as our ID is equal to the other ID, then we're good to go. For the hash code, then we're going to get our ID's hash code. All right. Just like we did for the other class. Wow, that was a lot of work to do. Okay, now we've created the database node as well, as the caption indicates. So what we need to do now is just to make sure we have all our constants in place before we carry on. Now remember, right after doing these classes, we're going to go ahead and create our the actual node service that talks with our database. All right. So before we do that, let's create all the necessary constants, such as the file under which our database is going to be saved. So let's just call it db name, and we're just going to call it notes.db. All right. Remember, this is like the file name, okay, that we're going to create. And you can see in here in our file here in DB browser for SQLite, we call this file testing.db. And in our case, we're just going to call it notes.db. And we're going to store it in the documents folder inside that application, okay? And then we have two tables, a note table and a user table. So let's go ahead and create them. Note table is note and const. User table is user. And these are like the table names as we define them here, note and user. Okay. So those are those. And what else do we need? I think that's pretty much it, to be honest with you. I think these are all the constants that are needed in order for us to be able to create our notes service. All right, let's go ahead now and start with our notes service. So I'm gonna clear this, go to the top of this file, and then gonna make some empty space in here and actually create our notes service. So let's go ahead and create a class here and call it notes service. This is very exciting. This is the beginning of us creating a CRUD service that works with our database, which we're soon going to create actually, okay? As the caption indicates, we need a function, an async function that opens the database. You see, opening a database is not a functionality that you can just say, oh, open now. It will happen asynchronously because we may need to, for instance, grab the current folder, the documents folder, and then append or join that documents folder with our database name, which we define here as a constant. So it's a lot of asynchronous stuff that are going to happen in there. Well, not a lot, but a few at least. And that is the reason this open function is going to be asynchronous. Okay. So as the caption indicates, let's go ahead and create a future void and call it just open, and we'll call it async like that. Now, this open function is going to keep hold of, after it has opened the database, is actually going to store it somewhere in our notes service. So it's going to say, hey, I've opened the database. Here is the object, so that other functions in the future, such as the functions that are going to let us read users from the database or you read notes from the database, those functions, then they're going to say, oh, here's the database instance. I know how to grab values out of it. Okay, so what we're going to do is to say we have a database. And as you can see, it is brought by our SQFlite library. And we're just going to call it DB. All right, so to begin with is null, and we're going to assign to it. All right. So what should we do now? Let's go ahead then and start by doing a test and see if this database is already opened. You see, if we have an instance of this database, then we can kind of like assume that this database file has already been opened and we don't have to open it anymore. So let's just say if the DB is not null, and just throw a new exception. And we're going to just call it a database already open exception. So let's go and define that exception here. Let me see if I can copy and paste that from my notes. So you see, this is just an exception. That's a database already open exception. All right. So in here, we're just going to say database already open exception. All right. So simple. If you call the open function multiple times while the database is already open, you're going to get an exception. Okay, so that kind of makes sense. So let's go ahead and now get the document directory path. And we have to do a try in here because this can actually throw an exception. So let's say final docs path is equal to, and you need to say get application documents directory. If you have a look at the signature of this method, it says I return a future of directory. So let's go ahead and do that. So we need to await on it, and that's the reason our function is async, and that's the reason we're awaiting, because this returns the path asynchronously. Now, if you look at the documentation for this, you can see that it can actually throw an exception called missing platform directory exception if the system is unable to provide the directory. All right. If for some reason the system isn't able to provide a document directory to us, it's going to throw this exception. And that is exactly why we have our code inside a try statement here. So let's say if that exception is thrown like this, then we're going to throw our own exception. So let's define an exception. We call it unable to get documents directory. This. So it's just a class unable to get documents directory. Exception. Nothing special about that. Okay. And then in here we say throw at the name missing platform. I see. You see, it's complaining now, and I can see that you couldn't see the codes. I apologize for that. It's complaining and saying that I can't find this missing platform directory exception, and that is because this is specified in this path provider. But for our path provider, we just say show get application documents directory. So all other symbols are hidden from us. So we could just remove that and just say import the entire path provider, and that error goes away. All right. Okay. Now let's do this. Now let's say, I apologize. Let's get the actual path of our database. So to do that, you will say, what are we calling it? DB path is equal to join. Remember, we have this function join here that we imported from path. Then we say join the docs path and our DB name. Remember, the DB name was a constant as a string. We define it down here. We just call it notes DB. That is now going to be joined with the actual path of our documents folder. All right. And what we're going to do is we're going to say we now want to open the database with a function called open database, which comes from SQFlite. And the path is DB path. And remember, this open database, I believe, is a future of our database, you see. So we await on it. All right. And then we assign that to our local database instance. That's it. So that was basically opening the database. So we've now opened it. But remember, all we've been working on right now is inside this DB browser for SQLite. This program here is managing its own database file. This database file is not going to exist in your Flutter application. We've just played around. I just showed you how to create a SQLite database, how to create different tables, what fields are, what primary key is. So you need to kind of like forget about this application and where it stores its data. You need to now focus on how is your Flutter application going to be able to create those tables? How is your Flutter application going to be reading data from the tables or deleting data from the tables? So if you think about it, if you've completely forgotten about the DB browser for SQLite, then you could just say at this point in time, you see Open Database also can create the database for you if it doesn't exist. We can look at the documentation for it here. Oh my God. Opens the database at a given path specified the system on is the first, let's see, on create is called if the database did not exist prior to calling open database. Okay, so it can create the database for you, which is what it's going to do. But those tables are not going to exist, and we have to have a way of creating those tables if they don't exist upon us opening the database. Okay, and that's what we're going to do here. So let's go ahead and actually grab the code for creating the user table. So I'm just going to say const create user table is equal to, and this is now I'm going to actually use a syntax that we haven't used before, and that's triple quotation marks. Okay, and then triple quotation marks on the next line, and then a semicolon. Now what this does is that it allows you to place pretty much anything inside this string without you having to escape that string, because triple quotation marks are very unique. So even if you paste any other programming languages code in here, chances are that programming languages code is not going to include three quotation marks. So the purpose of this is that now you can go ahead in your SQLite, DB browser for SQLite, and grab this user's, if I go here, database structure, user, modify table, and you can literally now grab this code that was created by DB browser for SQLite and paste it in here, you see? So there we go. Now you have a beautiful database creation code in here. Sorry, table creation code that says create table user, blah, blah, ID, integer, not null. However, we need to take care of something in here, and we just say if not exists, I believe. And we have to put it before user as well. So that's the only thing we're adding here. We're basically saying create a table, call user, if it doesn't exist, because you see, we don't want to get an error, because if you create a table that already exists in the database, then SQFlite is going to throw an error saying that this table already exists. Okay, so that's why we need if not exists. And then what we need to do is to tell our database, this database that we created up here, to execute that command. So we're just going to say execute, and you see it says give me a SQL to execute, and I'm going to give you a future void. Then we say okay, execute create user table, and we await on it. Some comment in here, we just say create user table. And then in here for the, after we've executed the create user table, we also have to then take care of the creation of our node table. So I'm just going to do the same thing that we did up here. I'm just say create note table equal to triple single quotes, triple single quotes, semicolon. Let's go to DB browser for SQLite and grab this note here and say modify table and grab the code that was generated for you and just paste it in here. Do some formatting so it becomes a little bit more bearable to read and have a look at. And we do the same thing that we did up there. We say if not exists, like that. All right. So I think to be honest with you, we're good to go there. I don't think we need to do anything special in there. We also have to execute that command. So I'm just gonna grab that code from there, paste it right here, and like that. And I'm gonna say create node table. So that's gonna do the creation of the node table as well. Well done. That was it. That was a big function. I mean, by the standards of what we've done so far, that was quite a big function. Okay, but generally, this is not considered such a big function. And remember, now you have actually constants in here. You could, I mean, if it's me deciding, I would bring this constant somewhere else, not inside this function. We could literally go ahead. I mean, I hadn't planned for this, but let's go ahead and grab this constant from here and bring it to the end of this file, okay, where we have all the other constants like this. And let's go and grab the other constant from here, boom, and bring it down as well. So we put it at the end of our file right there, okay? As I said, I hadn't planned for this, but I just think it makes sense because now our function is a lot cleaner to have a look at. Here we have a comment for create the user table. Let's create a comment as well here. And we say create node table and remove those empty spaces and just save your file. Perfect. Now we have the open function. Let's go ahead and have a look at how we can do closing of our database. All right, I'll have a look at my notes in here. Okay, let's have a look at our closing code. So I'm going to fold the open function in here so we don't see it anymore. And let's go ahead and create, as you can see in the caption, we have to say future void close. Okay, and it's asynchronous. So what we need to do then is we shouldn't allow any person to close the database if the database is not open. So let's go ahead and define an exception for that. And we're going to call the database is not open. Okay, so I'm going to copy that exception so I don't have to type it manually because by this point, you know how to create exceptions. So it's nothing extraordinary for you to learn. Database is not open. That's a new exception. Okay, so what we're going to do is we're going to say we have our database. Final DB is equal to our local DB up there. And we say if DB is null, and then we throw database not open. Oops, database is not open. Else, we're going to ask SQFlite to close that database for us. And a way to do that is just to say db.close. And you can see it's a future of void, so that's why we're waiting on it. All right. And then at that point, we have to also reset this local database, which is called underscore DB. So we say DB is equal to null. All right. So easy peasy, close went very fast, actually. All right. Now what we need, you see, as we have to open and close, now we're going to start working with data in the database. But in order for you to get like your database so that it can, for instance, actually grab like every function that tries to read something from the database, it has to have some code in order to make sure that the database is open. Otherwise, it has to throw an error. So we're going to have like 5, 6 of these functions, and each of which is going to check the database and then do the same thing. Is the database open? Yes. If it's not open, throw this error. We could put that particular code inside another function that we are going to call get database or throw. Okay. So let's go ahead in here and just say this function returns a database, get database or throw. And we prefix it with an underscore saying that this is a private function. And then we're going to say final db is db. If db is null, and we say throw database is not open, else we return the db. Okay, so this is a private function that our reading and writing internal functions in this class are going to use in order to get the current database so that they avoid doing the same if statement everywhere. Okay. All right, now we're going to start with actual code. So to read and write from the database. In this case, we're going to start with a function called delete user that allows us to provide, as you can see, an email address. And using that email address, then we're going to delete that user from our database. So you will learn how to manipulate data from our or inside our database. Okay. So let's go ahead and do the function signature as it's indicated here. I'm just going to say future void delete user and required string email and make this function asynchronous. Okay. Then what we're going to do is just to get our database with this absolutely beautiful get database or throw function that we created here. So I'm just going to say final db is get database or throw. So this in turn is going to throw an exception called database is not open if the database is not open. So we don't have to manually do that. Okay. So in order to delete something from SQFlite, or in this case SQLite that is managed by SQFlite, we can say db dot delete, and as you can see, it returns a future of the number of rows that were deleted, and then it says, okay, which table, and then a where clause and a list of objects to pass to your where clause. So we're going to say the delete from the user table, and the where clause is going to be email is equal to something, and the where args are in this case are going to be email to lowercase. Okay, so I'm going to put a semicolon there and a colon here, and then we're going to await on it, and we're going to say final deleted count is await. So in this case, I mean, as you can see, here's what we're basically doing is just we're doing formatting. We're going to say delete something from the user table as long as that something's email is equal to something, and that something is again that email. So you're basically saying delete as many objects as possible in the user table as long as their email is equal to this. And remember, we made email unique. So if we've done our homework right, then deleted count is it should either be 0, meaning that no account or no user with this email existed into the table, or it should be 1, meaning that yeah, I could delete without a problem. So we're actually going to assert that. We're going to say if deleted count is not 1, all right, then we're going to throw an error, could not delete user. So I'm going to grab that exception. I'm going to place it right here. So we say if we couldn't delete that user, we're just going to say throw could not delete user. All right. So we couldn't delete that user. All right, so let's go ahead now that we have done the delete user. And remember, you may be asking, okay, but why are we throwing a user? Maybe that user doesn't exist and it should just work fine. And of course, I mean, it is going to work fine if you have your try and catch statements when you call this function. What we're saying is that the interface of the node service is going to throw an error, throw an exception if you call delete user with a non-existing email. And that's completely fine for a service to do. But where you're consuming the service, then you can manage and say, oh, this delete function is going to throw an exception by, like, for instance, looking at the documentation, looking at the code. Then I'm going to handle it where I'm calling it as at the call site, which is called, okay? So this is completely fine for a service to do. Then what we're going to do as the next point is to create a user, and you can see it's going to be a future of database user. So this is beautiful. It's going to actually create a user, give it an email address, and then it's going to return that database user to us. So let's go ahead and do that. Let's just say future database user, and we're going to say create user and a required string field of email, and we're going to make it asynchronous. All right. So in here, what we're going to do is just going to get the database. We're going to say final db is equal to get db database or throw. And then we're going to say db.query like that, because we're going to actually issue a query to the database. Okay. So as you can see, this is a helper to query table and return the items found. All optional clauses are unfiltered or formatted as SQL queries. Okay. So let's go ahead and in here, what we're going to first do, the first thing we're going to do in create user, now we're going to actually check if a user with a given email already exists. Okay. And that's why we're doing query, and we're not like inserting something into the database to begin with. We're asking the database to say, hey, does in the user table, we're looking for, we're querying the database for a person or a user whose email is this. And that this thing is actually going to return, let's have a look at it. It's going to return a list of rows that were available in the database. Okay. And that list is going to be empty if no entities matched our query. Okay. So let's just call it final results is we're querying the user table, and we're going to say we're looking for just one item, and we have a where equal to, we're looking for the email, and where args are going to be email to lowercase, semicolon at the end, and bring it like this, so equal to db, and we await. Okay. So by us first making a query to the database and checking whether a user with the same email exists, we're basically avoiding getting an error for the uniqueness of that email later on at the SQL layer. So in this case, you can see results. If I move my mouse over it, it says that it is a list of rows. And if this list is not empty, it literally means that a user with that email address already exists in the database. So let's then say if results is not empty, then we're going to say throw user already exists exception. And we don't have that exception yet. So let's go ahead and find that exception for me at least, and I can paste it right here. So define this exception, user already exists, and let's go ahead and throw that exception, user already exists. Okay, so that's our if statement. So at that point, we've basically made sure that that user does not exist in the database. All right, so what we need to do then is to go and insert that user now that we've checked that he or she doesn't exist in the database. So we have to go and insert that user. So the way we do that is by going and telling our database, we say db insert, and you can see it says in which table, and then give me a map of keys and values, which is the column name and the value for that column. All right. So let's just say we insert into the user table, which is a constant we've defined from before, remember? And then the map is going to be for the, let's go back to our DB browser for SQLite. For for user, for user, we have ID, which is primary key, not null, and auto increment. So we don't have to insert the ID, but we need to insert the email. So let's go ahead and say we have the email column is equal to it's going to be equal to email to lowercase. All right. So like that, and insert, if you can have a look here, it returns a future of int. And if you read the documentation, let's see if it gives us some documentation here. 0 could be returned for some specific conflict algorithms if not inserted. So this is going to basically give us the so what it's going to do in this case is actually going to give us the user ID back. I wish there was some good documentation about it. Here you can see it says insert returns the ID. So this is very, very good. This is actually really cool because remember, we said we return a database user, and a database user actually has an ID in it. So if this function here did not return the ID, how else would we get the ID? Then we'd have to insert and then read that same user in order to get the ID, but we don't have to do that. So in here, then we say final, and we say user ID is equal to await on this functionality. And then we just return a database user. Bring it up so you actually see the code. Then we say user ID, and the email is email, the way it was before. Okay, add a column there. Fantastic. Now we've taken care of the create user function in our database. So that's create user. I'm going to follow this. So now we have create user, delete user, and open and close, and a private function in order to get the current database. Okay. As the caption indicates, now we have to take care of a function called getUser, which it can retrieve a user given its email address. All right, so I'm going to go ahead and basically write that function signature here by pasting it from my notes, so I don't have to type it manually, but you have it in the captions in case you need to go to it. We, just like we did in the other functions, we're going to get the current database or throw an error if the database isn't open. So we're going to say db is get database or throw. Then what we're going to do is we're going to query the database for that email address. And if you remember, in the create user, we already did that. So let's go and copy that, boof, like this. And I'm going to fold create user, and let's go in here and paste that code. We have the results, okay? So in this case, we have to do the opposite. You see, in create user, we checked to make sure that the results are actually empty, because we wanted to make sure before we create a new user with that email doesn't already exist. But in this case, we actually have to do the opposite. When you want to get a user, we want to make sure that it does exist. So we have to say if results is empty, meaning that we couldn't find this user with the given email address, then we say a throw could not find user. Actually, we don't have that yet. So we need to define a new exception called could not find user. And I'm going to bring it up here. Just like we have could not delete user, we also have could not find user. Okay. And then here we have to throw that could not find user. All right. So if the results were empty, then we throw that. Otherwise, we have to then construct a database user. So we say return database user from row, and we say results dot first, which is the first row that was read from the user table. Also remember we set a limit of 1, so it should be either 0 rows or 1 row, which is the user with the given email address. Okay. All right, perfect. Let's go ahead to the next function that we have to implement, and that is for us to be able to create new nodes. So if you want to be like me and clean up the code a little bit here, just fold everything so you only see the function signatures. Now we can focus on the next function, which is create nodes. I'm just going to find it in my notes here just to make sure I give you the exact code necessary in order to create the create node function. If I can find it, create nodes right there. Okay. As the caption indicates, we have to have an asynchronous function called create node. It returns a database node, and it also says who is the owner of this node. And it's just going to create a new node with an empty text, and it's going to associate that node with the given database user. And you see the parameter is of type database user, and a way to get a user is either to create one if it doesn't exist and you get a database user, or you get an existing user. Okay, so excuse me, let's go ahead and say future database user, and we call this function, as the notes indicate, create node, and we say is a required field of a database user. Oops, sorry, it shouldn't return a database user, it should be database nodes. All right, and the parameter is the owner, which is the database user, and it's an async function. So just like we did in the other places, we're going to say final db is get or throw, get the current database or throw. So what we need to do first is just to make sure that the current user that we are passing here already exists in the database. Because remember, database user is just a class. It can be created by calling its constructor, which is right here, somewhere here. So I could just create a new database user instance and say database user and a random email and a random ID. But in here, when we're trying to create a node for that particular database user, we need to first make sure that that database user is actually inside the database, okay? And to do that, we say final db user is equal to await, and we actually call our own get user function in here. We say get user with the email of the owner's email, owner email. So in here, we're literally reusing the code that we've created. Then what we're going to do is we're going to check whether this database user is actually the owner. See, What do I mean by that? I mean that let's say that I go and hack things up and I say, oh, I create a new instance of database user manually without inserting it into the database. And here's the ID, some sort of a random ID. And then here's the email, which I know exists in the database. Now, what we need to do in our code is just to make sure that the ID that you provided in your database user here is actually an ID of an existing user in our database. And to do that, we could literally use this little beautiful function that we wrote earlier, which is the equality function of our database user, which actually checks our ID against the other database user's ID. So if we literally say here in here, we say if the DB user is not the owner, which goes into our equal operator and negates it. It says, oh, if it's not equal to that, then we say throw could not find user. Okay. So after this place, if we actually found the DB user with that email and the ID was exact ID as the owner, then we can actually be sure that that user does exist in the database with the correct email and the correct ID. Okay, so let's just put comments in here and say make sure owner exists in the database with the correct ID. That's it. Okay. All right. After we've done that, we also have to take care of actually creating the note. So let's go ahead and create a text. And here we say the text is, I noticed that you couldn't see that code. I hope that you saw this code at least that I wrote here. But if you didn't, I apologize for that. It's just because I'm using a software that I don't see the software all the time on my main monitor, which is the monitor that I'm coding. I have to look at a secondary monitor, which is down here. So I'm doing my best to look at that secondary monitor just to make sure you're seeing all the content, but sometimes I could miss that. I apologize for that. So let's see that. Now you can see this code. All right, I'm going to bring this code a little bit up. So let's go ahead and actually create the notes. So I'm going to put a comment in here and say our work now is to create notes, create the notes. And what we're going to say, DB insert, just like we did an insert previously for create user, we're going to do a DB insert for the notes, and it's in the note table. And you see the values in here, it's going to be a map. And the map is, if you look at the insert function, is literally a map of string and objects. So let's have a look at our note table in here. And you can see note, right click, modify table. It needs user ID, text, and is synced with cloud columns. So let's go ahead and say user ID column, user ID column. It's the owner's ID. And we had, what else do we have? We had the text column. And that is equal to this text that we just created up there, which is an empty text, basically. You don't have to do this. You don't have to do that part. You could just literally just say this. To me, it's more readable if I define these things beforehand like that. Okay. And then in here, we just say is synced with cloud column, and its value is 1 in this case. So we're basically saying that we start off with that. Okay. And I just noticed that I had missed a column in there. Remember, insert, it returns the ID of the inserted object in the database, and it's a future. So let's then say final note ID is equal to a waiting on that function to insert the notes into the note table. All right, now that that is done, we're going to actually return a new note instance and return it, a database note. So what we're going to do in here, we're going to say final note is equal to database note, like that. And for the ID, we're going to say note ID. I'm going to bring it up so you see it better. And for the user ID, we're going to say owner ID. Text is text, so this is another reason to have it defined like a constant like I did, so that we can reuse it here and there. And is synced with cloud, what should we do there? We should probably just say true, okay? After creating a note, you have to return it then inside your asynchronous function, all right? I want to put a comma here as well, just to make sure formatting is in place. All right, now we inserted notes into the database, and we also created a database note to return that from our function. Wow, a lot of code, but I hope you're sticking with me throughout this chapter. So now we have create note. As the caption indicates, now we have to work on a function that allows us to delete a node, because remember, we're going to allow the user to select a node in the database later, select a node on the user interface, which that user themselves have created, and be able to delete that node. All right, so we need a function that allows us to delete a node using its ID. All right, so let's go. I'm just going to bring the basics of this function, or almost the entirety of this function actually here, so we don't have to code that manually. I'm going to paste it here. And as you can see here, the signature of this function, I'm going to explain it all. The signature of this function is called delete node, and it's an asynchronous function, as the caption at the bottom of the screen indicates. We do the get db, and then we're literally just calling the delete function, which is the exact same thing which I believe we did in delete user. Let's have a look at that. You see delete count, db delete in the table, and then your where clause. And in this case, inside the delete node, we're saying from the node table, delete an object which has its column ID equal to something, and then we're passing that something in the where args. Now, if we couldn't delete anything, if that node didn't exist with the given ID, then we're throwing an exception called could not delete node, and that's an exception that we haven't defined yet, and we're going to have to define that at the bottom of all the other exceptions that we've defined so far. So that's could not delete node implements exception. All right. So I thought I usually don't copy paste code, even if it's my own code, but I thought this is such an easy code. We have literally done every part of something similar before. We've done the get db, we've done the delete before, we've done this if statement before. So it's nothing new. And I don't think you have to have me here spending time explaining the same thing over and over again. And that's why I copy pasted this delete node here. Okay. All right, then what we need also is the ability for us to delete all nodes from our database. How do we do that? As you can see, we need a function called future int, which indicates a number of nodes that were deleted from the database. We call it delete all nodes, and it's an async function here. Okay, and what we need to do in here is it's very simple. We're going to say final db is equal to get or throw, and then we say db delete, and then we just literally say note table, boom boom, await on it. All right, and you see this, if you issue the delete command on your database with a given table, what it does is that it deletes every row inside that table for you, and it will return the number of rows that were affected. So you can see it returns the number of rows affected. So that's exactly what we want to return. So just return that value in this function. All right, perfect, good stuff. We've done some big functions and some small functions, so it's so refreshing to have some small functions as well, even for me. So what we need to do now is to create the functionality for fetching a specific node. You see, when we actually get to the UI where we render all the nodes that are inside a database to our user in the main UI of our application, we're going to list all the nodes. And then if the user presses on any specific node, then we're going to get the ID of that node and then read that node's information from the database. And that's why we need a function that takes an ID of a node and actually grabs that node for us from the database. Okay. So let's go ahead and program that. So I'm going to bring the function signature, and we're not going to copy paste it this time. We copy paste the function actually, I mean. So let's go ahead and get the DB. So this is easy for you now. You know how to do that. And we're going to query the database. So we're just going to say final nodes, which is going to be like the iterable list of maps that the SQLite database can read. So we're going to say await on the DB query, and we're going to say in the notes table, I'm going to remove all these overlays so you see the code better, notes table, and we're going to just say limit 1 because we want to get 1 note, all right? And the where clause is going to be using its ID. You see, we're going to say ID equal to something, and the where args are going to be just the ID itself, like that, boom, and a semicolon, like that, all right? Now, if this notes, which is, you can see as a list, if notes is empty, we're going to throw an exception. So we're going to say could not find notes. Do we have that? could not find user we have, could not find notes we don't have. So let's go and define it. I'm going to bring it from my own notes, so we don't have to write that manually. So define an exception called could not find note, implements exception. All right. And in here, we just throw it. Could not find note. So if you gave us an ID, we couldn't find it in the database, we just throw an exception. Otherwise, we need to actually create an instance of our database node. So we say return database note from row and notes first. Okay. So that's similar to how we did it before for getting a user as well. All right. Now, we also need a functionality that allows us to get all nodes in the system. You see, we have get node, delete all nodes, delete node, create node, but we don't have any functionality that can get all the nodes. And that is the exact function that we're going to use in the main interface of our application to render all the nodes for a given user. Okay. So let me just make sure that I have that function in here. And it is called get all nodes. Let's see. If we can find that functionality, get all nodes somewhere. Create node we have. Get user we have. And perhaps I don't actually have the functionality right now. I can see in my notes that I don't actually have get all nodes, but that is actually not a problem at all. In the get node here, you see we have to define this get all nodes. So let's go ahead and do that. I'm going to copy the signature of this function. And I'm going to bring it here, and we're going to say we're going to return a future of list of database nodes, and we're saying get all nodes like this. All right. Excuse me. And it shouldn't require any parameters. We're just going to ask the database to return all the nodes. All right. Sorry about that again. And I'm going to copy the functionality from here for get nodes. Excuse me again. And in here, we're not now going to limit anything, and we don't have any where clause. Okay, so just like that, we're going to say db query from the node table, and we get all the nodes. Then if nodes is empty, then we say could not find nodes. Or perhaps we could just say nodes. We can see it's a list. We could literally not have any special logic in here that says could not find node or anything. I'm going to have a look at my notes in here. Yeah, that's fine. What we need to do now that we have our nodes, we can map them. So we say nodes map, and you can name this parameter n. And in your mapping, you need to say, okay, I get a database node, which you can see is of type. Let me see if I can move my mouse over here. Is a map of string object. This matches perfectly into our database node. Dot from row, and then you say from this n. Let's actually call it node row or something like that. And we put it there. And if you say final result, and now I think this is an iterable, to be honest with you. So you can see it's an iterable of database nodes. Okay. So what we could do is actually change our future in here. Instead of saying list, we return an iterable. Okay. So in order, for the sake of cleanliness, I'm also going to change our captioning here and say iterable. So you see the correct information on your screen as well. All right. So that's our result. So all we need to do in here, just to return it. That's it. So like that. Perfect. So, and that's the functionality of get all nodes. So it's very simple, nothing special. And now what we need to do is, just to wrap it up, there's one last function that we have to implement. And remember, when we go to the main UI of the application, we're going to allow the user to create nodes, list all their created nodes, and also be able to click on any specific node in order to update the contents of that node. So we need a function called update node. So let's go. I'm going to bring my notes in here. Update nodes. So let's go ahead and create the signature for that function, future database node. And we say update node like that. And we're going to have some required parameters, which we actually grab an existing database node object, and then we expect the user to also provide a new text. So let's just say required database node, and then we say required string of text, just like that. It's an async function. Okay. You're already familiar with this. We're going to get the database. We say get or throw. Okay. And we're just going to issue an update to our database. We haven't done updates before for our SQLite database, so that's what we're going to do now. So let's just say db.update. And you can see it says give us a table, or give me the table and your list of updates. So let's go in here and say update the note table. And actually, before doing that, how do we make sure that this table, that note already exists in the database? Because like we saw earlier, anybody can go and add or create an instance of a database node. It doesn't necessarily have to be in a database, but we kind of need to make sure that it already is stored in the database, because before we can update its text. So we already have a functionality that does that. Remember, gets note with an ID. So we could literally just say await gets note, and then we say note ID. And you see, this actually throws an error. If you go to this function, it throws an error called could not find note, which is exactly what we're after. But we're not actually after the result of it. We don't want the actual note, because we're assuming that that is the same object as this. So we're just ignoring its return value. Okay. In the update, we're going to say the note table, and the values that we're going to provide are two. We're going to say the text column is going to be the new text. And upon you updating the text of a node, we're also going to assume that, well, all of a sudden this node is not synced with the backend or with the data, with the cloud database anymore. Okay, so that goes back to our is synced with cloud column. So let's go in here and say is synced with cloud column, then it's going to be set to 0. Remember, that was an integer field. All right. Update is an asynchronous function, so you have to wait on it. And it also returns the number of rows that were updated. So we're going to say updated updates count. Final updates count is equal to await on DB update. All right. Now, by you at the call side calling the updates node function, we're assuming that that node should have existed in the database. Okay. So in this case, the updates count should be a value other than 0. Okay. So we say if updates count is equal to 0, bring the code up so you can see it. Then we have to throw a new exception called could not update node. I'm going to paste that exception from my notes. So it should look like this. Class could not update node implements exception. All right. So I need you to write this code as well. And if updates count is 0, then we're going to say throw could not update node. Else. Now you can see what we promise is to return a new database node. So let's go and just say, do we then? I mean, that's the thing. We've updated that, and how do we return a database node to you? Well, we could just do this. Return gets note with that note ID, because we already have gets note function implemented. All right. Wow. Very well done if you could stick with me throughout this chapter, because we did a lot of work. So I'm going to fold this. You can see we have a lot of functions here, quite a lot of work. And I think so far this has been the biggest chapter of this course. But we've also had a lot to do, a lot of information. I hope you could stick with me. Let's go ahead now and clean up our exceptions as the caption indicates. Let's put all our CRUD exceptions in one file inside lib services CRUD underscore CRUD exceptions. Okay, so let's go in here and actually it should say CRUD/CRUD exceptions. So if I look at my notes inside services CRUD, I'm gonna fix this caption. I apologize for that. I'm just gonna fix it on the go like this, and I'm gonna bring it up. And actually it should say CRUD/CRUD underscore exception. So I think there was more than one error in there. CRUD exceptions. So it should be lib services CRUD/CRUD exceptions. All right. So let's go and fix that up. Inside services, we have CRUD already, and we have nodes service Dart. Let's create a new file in there, and we just call it CRUD exceptions.dart. Now I need you to go into your node service Dart file and grab all those exceptions that you defined here and just cut them with Command X on Macintosh or Control X in Linux and Windows, and then bring it into your CRUD exceptions. All right, and save this file. And let me also have a look here. Just to make sure my notes are clean as well for you. So because I noticed that the next caption was also a little bit incorrect. Now we need to go and use that CRUD exceptions in our node service, because as you can see, it is marked as red right now because there were so many exceptions thrown that this file doesn't have access to anymore. So I'm going to get help from Visual Studio Code here with command dot and say import CRUD exceptions, and all those errors are going to go away. All right, well done. Huge chapter. A lot of work done, and congratulations for sticking with me through this chapter. Now, as is the tradition, we're going to now go ahead and commit our work and also tag it. So I'm going to make the screen a little bit bigger. Let's go to our terminal here. And I'm then going to say in here, we're going to tag and commit our work as step 11. So let's first get status. And then we say get add all, get status again. Here are the things we've done. Pop spec was changed because we added 3 dependencies, path provider, path, and also, I believe actually it was called path and path provider, right? Yes, path provider, and SQFlite. So that's why these 2 files have been changed. Node service is completely new, and CRUD exceptions is also new. So git commit, step 11, as the caption indicates. Git push the commits first, remember, and then we tag it as step 11, and we push our tags as well. Oh, fantastic. Now, congratulations again for going through this chapter with me. It was a huge chapter, I think the biggest so far. Now we need to get ready for the next chapter, as is a tradition for the other chapters. At the end, we talk a little bit about what we're going to do in the next chapter just to get ready for it. So we've done a lot of work on the data. Now we need to fuse it together with our UI. And in order to do that, we need to talk about streams and stream controllers. You see, when you're in the main UI of your application, after you've logged in, you need to see a list of your notes. But what happens if you see the list of your notes and then you press the plus button to create a new note? And this plus button is a button that we're going to create soon in the next chapters. What happens if you press the plus button? Should you then send manually a signal to your UI and say, hey, a new note was created, update the list? That is a lot of work. And for that, you can do things a lot cleaner if you use streams and stream controllers. And that's what we're going to talk about in the next chapter. So you may want to have a short pause after this chapter since it was so big. So do that, please. Get your refreshments, coffee, tea, whatever you want. And I'll see you in the next chapter.